For a long time, the sky felt familiar, predictable, quiet. Every night, telescopes around the world scanned the same dark canvas, finding the same stars, the same planets, the same slow-moving rocks drifting through space. Astronomers knew what to expect. The universe, for the most part, followed rules. Until one night, something didn't. It didn't arrive with a warning. No alarm. No headline. Just a faint streak of light, moving faster than it should. At first, it looked ordinary. Another object slipping along the ecliptic, the flat highway of our solar system where planets travel. These things happen all the time. Space is full of debris, ice, rock, leftovers from ancient collisions. So the object was catalogued, labeled, filed away. Just numbers, coordinates, a name, and for a brief moment, that's all it was. But as the days passed, someone noticed something small, something easy to miss. Its speed. This object wasn't drifting like the others. It wasn't wandering. It was cutting through space. Clean. Direct. Fast. Still, no panic. Fast objects exist. Some come from far away. Some have strange paths. Astronomy is full of oddities, so scientists kept watching, quietly, carefully. And that's when the silence began to feel heavy. Because as the object moved closer to the sun, its behavior refused to settle into expectations. Every object that enters our system follows a pattern. Gravity pulls, light reflects, heat rises. The rules are old, reliable. But this one didn't seem interested in following them. As perihelion approached, the moment it would swing closest to the sun, astronomers ran their models. They predicted how bright it would become, how warm it should get, how its surface should react. And on paper, everything made sense. But when the first real observations came in, the numbers didn't line up. The brightness was slightly off. Not dramatic, not enough to make headlines, just enough to make someone pause. Then came the second reading, and the third. Each time the light reflected from the object shifted in a way that felt wrong, too smooth, too controlled. Most space rocks tumble. They spinned wildly, showing rough edges and uneven surfaces. This object didn't. It glided. Its light curve, the way brightness rises and falls over time, looked calm, measured, almost intentional. At first, astronomers blamed their instruments. They always do. Telescopes aren't perfect. Sensors glitch. Data gets noisy. So they recalibrated. They double-checked. They compared results across different observatories in different countries using different equipment. And still, the same pattern appeared. Quiet, consistent, unbothered. The object didn't flare the way ice should when heated. It didn't trail gas like a comet. It simply passed, like it had done this before. And that's when a deeper discomfort settled in. Because space is chaotic, violent, messy. Yet this thing moved with calm purpose through that chaos. No visible tail, no debris cloud, just a solid presence, slipping through the dark. Some researchers tried to stay practical. Unusual composition, they said. Dense material. Rare geometry. Reasonable words. Safe words. But even they couldn't ignore the growing list of exceptions. The object's reflectivity didn't match rock, or ice, or metal. Its surface didn't heat evenly. Its brightness didn't fade when it should have. Every answer created two more questions. And quietly, A new kind of observation began. Not just watching the object, but watching each other. Emails became careful. Phrases grew softer. No one wanted to be the first to say it out loud, because once you suggest something is not natural, you can't take it back. So instead, they asked smaller questions. Why does it maintain orientation? Why does it resist tumbling? Why does it behave more like a designed object than a broken one? The closer it came to perihelion, the more obvious the tension became. The sun is unforgiving. Its radiation tears things apart. It boils ice, cracks stone. Most objects react violently. This one didn't. It stayed composed, almost prepared, and for the first time, a thought surfaced. Unspoken, but shared. What if this object isn't reacting to the sun, but anticipating it? What if this isn't a visitor caught by chance, but something passing through? On purpose. The idea felt uncomfortable, not because it was proven, but because it wasn't impossible. Humanity has always looked at the stars, believing we would see danger coming, believing that if something important entered our space, it would announce itself. With fire, with force, with noise. But this object didn't announce anything. It whispered. It slipped into our awareness the way thoughts slip into the back of your mind, unnoticed at first, impossible to ignore later. And maybe that's what unsettled astronomers the most. Not that something strange appeared in the sky, but that it appeared quietly, as if it didn't need our attention, as if it had passed 1,000 stars before ours and would pass 1,000 more after. And as it continued its silent approach towards the sun, one question hung in the darkness. If this object isn't behaving like a natural body, then what exactly have we discovered drifting through the silence? And more importantly, why now? At first, the numbers looked normal. Clean, sharp, reliable. Columns of data filled the screens in observatories around the world. Speed, distance, brightness, size. Everything measured, everything logged. This is the language astronomers trust, more than intuition. Numbers don't panic. Numbers don't imagine things. And yet, something about these numbers refused to sit still. The object's speed was calculated first. Fast, yes, but not impossible. Then, its size. Based on how much light it reflected, scientists estimated how big it should be. A rough shape formed in their minds. Something solid, something ordinary. But when they cross-checked the values, the picture cracked, because the brightness suggested one size, while the motion suggested another. And the reflectivity didn't agree with either. Normally, these values support each other. They lock into place like puzzle pieces. This time, they slid apart. It was subtle at first, a small mismatch, easy to ignore. But astronomy doesn't allow loose ends. Every decimal matters. Every assumption gets tested. So they recalculated again and again. Different models, different angles, different teams. Same problem. If the object was as bright as it appeared, it should have been larger. If it was as small as the motion suggested, it should have been dimmer. But it was neither. It was both. As if the object was presenting two truths at the same time. Some called it a shadowing effect. Others blamed surface texture. Maybe it was long and thin. Maybe flat, maybe spinning in a way that fooled the senses. Reasonable ideas, comforting ideas, but none of them fully worked. When astronomers adjusted the shape, the mass didn't fit. When they adjusted the mass, the speed fell apart. Every fix broke something else. And the strangest part? The data itself wasn't messy. No noise spikes. No corrupted signals. The measurements were calm, almost elegant. This wasn't chaos. It was consistency, pointing in the wrong direction. That's when the phrase started circulating quietly in internal discussions. Non-converging solution. A polite way of saying, no matter how we solve it, the answer refuses to agree. And that's rare, because nature, even when strange, usually settles into one explanation. A comet behaves like a comet. An asteroid behaves like an asteroid. This object behaved like a contradiction. Speed without mass. Brightness without size. Motion without drag. Each value made sense on its own. Together, they didn't belong. Some scientists joked about it at first. Maybe it doesn't want to be measured. A laugh, a release of tension. But the joke didn't last. Because as more observations came in, the disagreement grew. Not wildly, precisely. The numbers didn't drift randomly. They disagreed in the same way every time, as if the object had rules of its own. And slowly, a quiet realization began to form. This wasn't a mistake that would disappear with better data. This was the data. One researcher described it later as trying to weigh a shadow. You can measure it. You can see it move. But the moment you try to define it, it slips. Another unsettling detail emerged. The reflectivity wasn't constant, not in a natural way. Most objects reflect light unevenly because of rough surfaces, craters, dust, ice patches. This object's reflectivity shifted smoothly, like a dial being turned. Bright, dim, bright again. No sudden jumps. No chaos, just controlled variation. As if different surfaces were being shown on purpose. Or worse, as if the surface itself was changing. That thought stayed unspoken. For now. Instead, teams focused on eliminating error. They checked star catalogs, removed background interference, accounted for solar glare. Still, the mismatch remained. And then someone asked a simple question. What if it's not one object? A cluster? A loose formation? But that idea collapsed quickly. The motion was too unified, too precise. Whatever this was, it moved as one. Another question followed. What if our assumptions are wrong? Not the data, the framework. What if we're treating this like a natural body, when it doesn't belong in that category at all? That's when the room usually went quiet. Because astronomy is built on categories. Planet, comet, asteroid. We understand the universe by placing things into boxes, but this object didn't fit. And the longer scientists stared at the numbers, the more uncomfortable that became. The object wasn't breaking physics. That was the problem. It was obeying physics selectively, as if choosing which rules mattered, as if optimized, engineered. That word hovered at the edge of thought. No one said it, but everyone felt it. Because once you allow for the idea that something might be artificial, everything changes. Your measurements stop being neutral. Your curiosity gains weight, and your silence becomes loud. So instead, they asked safer questions. Could it be hollow? Could it be ultra-thin? Could it be made of material we don't yet understand? All possible, all unlikely, and yet less unsettling than the alternative. As the object continued its path toward perihelion, the disagreement in the numbers became impossible to ignore. Reports were written, then rewritten. Language softened. confidence turned cautious, because science isn't just about discovering truth. It's about defending it. And right now, no one was ready to defend this. Not yet. Because if these numbers weren't wrong, if they weren't errors, if they weren't coincidences, then they were signals. And signals mean intent. As one observer quietly put it, nature usually hides its secrets in chaos. This thing hides in clarity. And clarity, when it refuses to settle, can be more disturbing than noise. So the question lingered in every lab, every late-night screen glow, every silent meeting. Is this just a calculation error, or are we watching the first real anomaly reveal itself, one number at a time? At some point, every mystery reaches a moment where numbers turn into a picture. For astronomers, that picture is called a light curve. It's simple, really. You track how bright an object appears over time, and you watch how that brightness changes. Most space rocks tell their story instantly. They wobble. They tumble. They spin like broken glass drifting in the dark. Their light curves jump up and down. Messy, uneven, chaotic. Exactly what you'd expect from something shaped by collisions and time. That's the signature of nature. So when scientists finally plotted this object's light curve, they expected noise. What they saw instead made the room go quiet. The line didn't wobble. It didn't spike. It didn't jitter. It rose and fell in smooth, measured intervals. Like breathing. Bright, dim again. Not random. Not accidental. Controlled. At first, no one reacted. They stared. They waited for the graph to update, for the chaos to appear. It didn't. The curve stayed calm, almost elegant. Someone zoomed in. Same rhythm. Someone zoomed out. Same rhythm. This wasn't a momentary glitch. This was the object's behavior. And that's when discomfort crept in. Because a smooth, light curve means something very specific. It means the object isn't tumbling. It means it's either rotating perfectly or not rotating at all. Both possibilities were troubling. Perfect rotation requires balance, symmetry. Symmetry, stability. Space doesn't usually grant those things by accident. Most asteroids are jagged, scarred, uneven. They spin wildly because they've been smashed, pulled, and torn apart over billions of years. This object didn't carry those scars. Its brightness changed like it was following a script, a beat, a timing. And the interval between peaks, consistent, too consistent. Astronomers began comparing the curve to known objects. Comets? No. Too smooth. Asteroids? No. Too stable. Even exotic shapes couldn't fully explain it. A cigar-shaped body might produce a repeating pattern, but not one this clean. A flat disk could reflect light evenly, but then the brightness would snap, not glide. This curve didn't snap. It transitioned, softly, as if easing from one state to another. Someone described it as polite. The light never screamed for attention. It whispered. And that was worse, because noise can be dismissed. Whispers demand listening. More data came in over the following nights. Same rhythm, same spacing, different telescopes, different wavelengths, still the same. That's when the question surfaced, not out loud, but everywhere at once. What kind of object rotates like this? Or more unsettling, what kind of object controls its orientation? The idea felt dangerous, because orientation control implies correction. Adjustment, awareness of position. And awareness leads somewhere science isn't comfortable going without proof. So instead, researchers tried to stay grounded. They modeled extreme cases, perfectly uniform surfaces, unusual alloys, strange ice-metal hybrids. Each explanation stretched plausibility, but still fell short. The light curve didn't just repeat, it held phase, meaning the timing didn't drift over days or weeks. Natural rotations slow down, they speed up, they change. This didn't. It stayed locked, as if guided. And then came the most unsettling realization of all. The light curve wasn't just smooth, it was efficient. No wasted motion, no chaotic energy loss, just enough variation to be visible and no more. That's not how debris behaves. That's how systems behave. Designed systems. At this point, a few scientists began asking a different kind of question. Not, what is it? But why does it look like it wants to be seen, but not noticed? Because the brightness wasn't extreme. It didn't flare. It didn't announce itself. If you weren't looking carefully, you'd miss it. Like someone standing perfectly still in a crowd, not hiding, just blending in. And suddenly, the calmness of the curve felt intentional, like restraint, as if the object was minimizing disturbance, passing through without drawing attention. That idea lingered longer than anyone wanted, because if something wanted to pass unnoticed, it would do exactly this. Follow predictable paths, emit nothing loud, reflect light gently, enough to exist, not enough to alarm. But still, science demanded restraint. Extraordinary claims require extraordinary evidence. So no one said artificial. They said unusual rotational stability. They said unexpected symmetry. They said anomalous light behavior. Words that kept the door closed while quietly turning the handle. But late at night, when the rooms emptied, when the screens glowed blue against tired eyes, some researchers stared at that curve longer than necessary, tracing it with their fingers, watching the rise, the fall, again and again. And a thought crept in, slow and unwanted. This doesn't look like chaos. This looks like intention disguised as calm. And that's when a deeper fear surfaced. Not fear of invasion, not fear of danger, but fear of irrelevance. Because if something can pass through our system, obeying physics, but not nature, then maybe the universe has always been full of things we never noticed. Not because they were hidden, but because they were quiet. As the object continued toward perihelion, its light curve remained unchanged. No evolution, no breakdown. Just that same smooth rhythm, steady against the noise of the cosmos. And one question followed every new data point. Why would an object with no known origin shine with such controlled rhythm? And what happens when that rhythm changes? There is a moment in every orbit where pressure peaks. Perihelion, the closest point to the sun. The place where heat bites hardest, where weak objects fracture and strong ones reveal their limits. Astronomers waited for this moment, not with fear, with expectation. Because if this object was ordinary, perihelion would expose it. Ice would boil, gas would erupt, the surface would flare and fade like every other visitor before it. The sun has a way of stripping secrets away, so they watched. carefully, quietly, and when the object finally reached perihelion, the universe blinked just once. At first, it appeared as a spike in brightness, sharp, brief, unexpected. One observatory flagged it as a glitch, a solar flare maybe. Instrument noise. These things happen when you stare too close to the sun. But before the report could be dismissed, another alert came in from a different telescope, different country, different system, same spike, same timing. Within seconds, more confirmations followed, across continents, across oceans. The brightness pulse wasn't random, it was synchronized. The object didn't gradually brighten like a comet. It pulsed, bright, then calm, as if responding to something unseen. As if flipping a switch, the room filled with quiet urgency. Scientists pulled up live feeds, compared timestamps down to the millisecond. They matched perfectly. That's when coincidence stopped being comforting, because random events don't line up like this. Solar interference doesn't strike with such precision, and natural outbursts don't repeat cleanly across independent instruments. Yet this did. One pulse, then silence, then another. Same duration, same intensity, not stronger, not weaker. Controlled, measured, almost deliberate. Someone finally said what everyone was thinking. This looks like a pattern. And patterns are dangerous, because patterns imply structure, and structure implies intent. Still, caution ruled the room. Extraordinary claims require exhausting ordinary explanations. So they hunted for causes: solar radiation spikes, magnetic field interactions, instrument crosstalk. Each explanation failed. The sun was calm, the background noise was steady, the telescopes were clean, and the pulse remained. Then came the most unsettling detail. The pulse only occurred at perihelion, not before, not after, as if the object was waiting for that exact moment. The moment of maximum energy, maximum exposure, maximum stress. Almost like a trigger. In nature, reactions happen when thresholds are crossed. But this threshold felt chosen, timed. The object didn't react chaotically to the sun's heat. It responded once, cleanly, and then stopped, as if saying, "I'm here," but not loudly enough for anyone to be sure. Some researchers argued it was a thermal flash, a surface layer heating and cooling rapidly. But that explanation stumbled too. Thermal flashes decay unevenly. This pulse didn't. It rose smoothly, fell smoothly. No residue, no afterglow, just a clean spike and silence. Others suggested rotation alignment, a reflective surface briefly catching sunlight. But again, the math resisted. For that to happen simultaneously across Earth, the timing would have to be impossibly precise. And precision like that doesn't come from tumbling debris. It comes from alignment, control. By now, the language in internal notes had shifted. Words like event replaced artifact, pulse replaced flare. No one used the word signal, but everyone felt its weight, because a signal implies a sender, and a sender implies awareness. That idea sat heavy in the room. Not panic, not excitement, something quieter. Like standing alone at night, realizing you're not actually alone. Some tried to dismiss the thought. "We're pattern-seeking creatures," they said. We see meaning where there is none. And that's true. Humans are good at that. But this wasn't a face in the clouds. This was data, agreeing with itself across the planet. Another pulse arrived. Same timing, same profile. That's when someone asked the question no one wanted to answer. If this is coincidence, why does it keep repeating only when conditions are perfect? Perfect alignment, perfect energy input, perfect timing. Perihelion wasn't just a point in space, it was a moment, and the object chose it. The pulses didn't accelerate, they didn't escalate, they didn't form a message anyone could decode. They simply existed, enough to be noticed, not enough to be understood. Almost like knocking softly on a door and walking away before it opens. Some researchers felt a strange disappointment. If this was a signal, it wasn't meant to communicate. Not clearly. Not yet. Others felt relief. Ambiguity is safer than certainty, because certainty forces response. And humanity doesn't know how to respond to this. As the object began moving away from the sun, the pulses stopped. No fading, no transition. Just absence, like a switch turned off. The light curve returned to its calm rhythm. The numbers settled back into their quiet disagreement. And the universe pretended nothing happened. But the observers knew better. Something had occurred at perihelion, something rare, something timed, and now it was gone, leaving behind nothing but records and questions. Was the pulse a natural reaction we don't yet understand, or was it something else entirely? A system checking its limits? A machine acknowledging energy input? A signal never meant for us, only passing through our line of sight. Science demands restraint, so no conclusions were drawn, no announcements made. But the mood had changed. Before perihelion, this was an odd object. After perihelion, it felt aware, not alive, not hostile, just deliberate. And that idea unsettled everyone. Because if we are forcing meaning onto coincidence, we risk embarrassing ourselves. But if we are not, then we may have just witnessed the first intentional act from something that never planned to be seen. As the object drifted farther from the sun, carrying its silence with it, one question lingered longer than the rest. If that pulse was a signal, who was it for? And if it wasn't, why did it feel like the universe paused? Just long enough for us to notice. Space is cold, not metaphorically, not poetically, actually cold. So cold that heat struggles to exist at all. Out there, temperature follows simple rules. Closer to the sun, things warm up. Farther away, they cool down. Every object obeys this. Every rock, every comet, every grain of dust. That's why thermal data is trusted. Heat doesn't lie. Or at least, it never used to. After perihelion, scientists expected one thing: a clear thermal signature. The object had just brushed past the sun. Radiation should have soaked into its surface. Heat should linger, then slowly fade as it drifted away. That's the rule. That's what always happens. But when the thermal readings came in, something felt wrong. The surface temperature was dropping. Not gradually, actively. Cooling faster than distance alone could explain. At first, the numbers were dismissed. Sensor lag, someone said. Angle distortion, another offered. Reasonable explanations, necessary explanations. So they waited for the next day to pass, and that's when it happened. The temperature rose again. Not sharply, not explosively, smoothly, like a controlled increase, as if heat was being added from within. The room fell quiet. Because that shouldn't be possible. There was no internal heat source, no radioactive decay strong enough to explain it, no tidal forces, no chemical reaction visible on the surface, nothing, just empty space and a warming object. Thermal sensors don't care about theories, they only measure reality, and reality was refusing to behave. The object cooled, then warmed, then cooled again. Not randomly, in cycles, each shift subtle but unmistakable, independent of solar distance, independent of rotation, independent of everything we understand. One researcher described it simply: it's regulating. That word landed heavily, because regulation implies feedback, and feedback implies awareness of state, not intelligence, not consciousness, just control. In nature, control systems are rare. Biology has them, machines have them, rocks do not. Yet here it was. A thermal pattern that looked less like passive heating and more like deliberate balance. Like a thermostat. The idea was uncomfortable. So again, scientists searched for natural causes. Could it be layered material? A surface that traps heat, then releases it? Possibly. But layered materials don't behave this cleanly. They overshoot. They lag. This didn't. The transitions were smooth, no spikes, no runaway heating, just adjustment. Then came the deeper analysis. Infrared readings showed that different regions of the surface were changing temperature at different times, not chaotic variation, coordinated variation. One side cooled, another warmed, then they swapped. As if the object was redistributing energy, managing it. That's when the word passive quietly left the conversation. Passive objects don't redistribute heat. They absorb, and they lose. This thing appeared to manage. A few scientists pushed back hard. This is overinterpretation, they said. We're projecting meaning. And maybe they were right. Humans are good at that. We see faces in shadows, intent in randomness. But this wasn't a shadow. This was a dataset, repeating itself. Thermal models were run, thousands of them. Each one tried to force the object into known physics. Each one failed. Not dramatically, subtly, by just enough to matter. The predicted curves never lined up with the real ones. They were always late, or early, or uneven. Reality stayed smooth, controlled. That's when the quiet fear surfaced. Not fear of danger, fear of implication. Because if an object can regulate its temperature in deep space, then it must have structure, layers, channels, possibly internal cavities. And once you accept that, you begin to accept something else. Purpose. No one said it aloud, but it hung in the air. Purpose doesn't have to mean intent toward us. It could mean survival, stability, longevity. A system designed to pass through stars without breaking down. That idea changed the emotional weight of everything, because suddenly this wasn't a strange rock anymore. It was a traveler, and travelers are built to endure. The object wasn't fighting the sun. It wasn't suffering under its heat. It was adapting, taking in energy, shedding it, balancing itself in silence, as if it had done this many times before, as if stars were just checkpoints. Some researchers began to wonder if perihelion wasn't a threat, but a resource, a place to gather energy, a place to recharge. That thought stayed mostly unspoken, because once you cross that line, you're no longer asking, what is it? You're asking, why does it exist? And science isn't always ready for that question. The thermal pattern continued for days, then weeks, always calm, always controlled, never escalating, never failing. No sign of stress, no cracking, no breakdown, just balance. That balance became unsettling because chaos reassures us. Chaos means no one is in charge, but balance suggests design, even if no designer is visible. Late one night, a scientist wrote a private note in the margin of a report. This object behaves like it wants to remain unchanged. Not curious, not aggressive, not reactive, just stable. That idea lingered, because stability is a goal. A goal implies optimization, and optimization implies intention. Somewhere, sometime. In its origin, as the object continued drifting away from the sun, its temperature stabilized again. No residual heat, no thermal scars. It left perihelion exactly as it entered it, untouched, unchanged, as if the most violent force in our solar system had failed to leave a mark. And that realization changed everything. Because the sun strips away illusions. It exposes weakness. It reveals truth. And yet, this object passed through its fire and remained itself. So the question grew heavier. What mechanism could manage temperature so deliberately in the vacuum of space? And perhaps more troubling, what kind of object was designed to never need a home star at all? At first, it was subtle, almost easy to miss. A slight change in brightness, a soft shift in how light returned to our telescopes. Not a flare, not a pulse, just a difference. In space, reflectivity is simple. Light hits a surface and bounces back. Rough surfaces scatter it, smooth ones reflect it cleanly. That's how we tell what things are made of. That's how we read their history. So when the object's reflectivity began to change, scientists leaned in. Because reflectivity doesn't change without a reason, at least not naturally. The first explanation was rotation. Objects spin. Different sides face the sun. Different surfaces reflect different amounts of light. That's normal. Expected. Comforting. But this wasn't that. The changes weren't gradual. They didn't match a steady spin. The reflectivity shifted suddenly, then held, like a surface had turned or something had switched on. Then, just as quietly, it shifted again. No dust cloud appeared. No gas trail followed. Nothing was being released. Nothing was breaking apart. The object wasn't shedding material. It was changing how it interacted with light. That distinction mattered, because when comets change brightness, they announce it. They bloom. They erupt. They leave scars. This object left nothing, just altered light. Infrared and optical sensors confirmed it. The surface wasn't cracking. It wasn't melting. It was behaving selectively. One moment, highly reflective. The next, muted. Then back again. No warning, no visible cause. And the timing didn't match rotation models. If it were spinning, the cycle would be predictable. it wasn't. The changes happened off-beat, as if responding to something else. That's when a new discomfort entered the room, because reflectivity control implies surface control, and surface control implies structure. Not jagged rock, not random ice, structure. Some scientists proposed layered materials, exotic compounds that alter reflectivity when heated. It sounded reasonable until the data refused to cooperate. The changes weren't tied to temperature. They weren't tied to solar distance. They weren't tied to spin. They happened when they happened. And always cleanly. No half measures. No in-between states. On or off. Bright or dull. Like shutters opening and closing. Or panels adjusting angle. That thought lingered longer than anyone liked. Because once you imagine panels, you imagine surfaces designed to move, and movement suggests mechanics. Not life, not intent, just engineering. At this point, the word artificial hovered close to the conversation, still unspoken, still avoided, because saying it would change everything. Instead, they asked safer questions. Could electrostatic charging explain it? Solar radiation can charge surfaces unevenly. But again, nature is messy. Electrostatic effects fluctuate wildly. This didn't. The reflectivity shifts were stable, purposeful, almost economical. No wasted motion. No randomness. One researcher noticed something else. The reflectivity changes often followed other anomalies. After a thermal shift, after a light pulse. Like responses. As if the object wasn't just reacting, but adjusting. That was harder to ignore. Because reaction is passive. Adjustment is active. And active systems have goals. Not motives. Goals. Stability, efficiency, preservation. The object seemed less like debris and more like something passing through space while protecting itself. Shielding, balancing, adapting, without noise, without excess, without attention. That quietness became disturbing. If this were artificial, it wasn't trying to communicate. It wasn't exploring. It wasn't observing us. It was traveling. And travelers don't stop to explain themselves. Some scientists tried to push back emotionally. This doesn't mean anything, they said. We're seeing patterns because we're looking too hard. And maybe that was true. But the data didn't feel stretched. It felt restrained, as if the object was doing the minimum necessary to remain intact, the minimum necessary to remain unnoticed, which raised a new question. If this were natural, why does it behave like it wants to avoid attention? Natural objects don't care if they're seen. They flare, they trail, they announce themselves loudly. This object didn't. It adjusted just enough to pass safely. The reflectivity problem deepened over time. More observations, more shifts, always subtle, always controlled, never dramatic, like a machine running in low-power mode. And the longer scientists watched, the clearer one thing became. This wasn't chaos. This wasn't damage. This was choice. Not conscious choice, functional choice, design choice. No one said it out loud, but everyone felt the weight of it. Because if an object can change how it reflects light without spinning, without shedding material, without reacting to heat, then we're not just watching space debris, we're watching a system. a system designed to endure space itself. As the object continued its journey away from the sun, its reflectivity settled again, quiet, neutral, as if it had completed whatever adjustment it needed. And once more, the universe returned to silence. But the observers didn't. They stared at the screens a little longer, replayed the data one more time, because the question refused to go away. Are we witnessing an unusual natural rotation or an artificial adjustment hiding in plain sight? And if it is artificial, how many others have already passed through our sky without us ever noticing at all? There's a moment in every investigation where the noise stops, not because answers are found, but because questions become dangerous. That moment arrived quietly. No alarms, no announcements, just a pause. Draft papers sat unfinished. Emails were written, then deleted. Meetings ended without conclusions. For the first time since the object was discovered, the data didn't move forward. It hovered. Scientists are trained to speak through evidence, to publish, to explain. Silence is not their instinct. And yet, silence spread, not coordinated, not ordered, natural, like everyone had reached the same invisible edge and stopped. In conference rooms, words changed, sentences grew longer, more careful. We observe replaced we conclude. Suggests replaced indicates. Certainty softened into possibility, because certainty carries responsibility. And right now, no one wanted that weight. It wasn't fear of being wrong. Scientists are wrong all the time. That's part of the process. This was different. This was fear of being right. Because the data wasn't collapsing under scrutiny. It was holding. Every anomaly still stood. Every inconsistency remained clean. Light curves stayed smooth. Thermal patterns stayed controlled. Reflectivity shifts stayed deliberate. Nothing faded with time. Nothing explained itself away. And the longer the object drifted, the less comfortable the explanations became. In private discussions, researchers began asking each other questions they never put in writing. How far can we go before this stops being astronomy? What happens if this isn't natural? What do we do with that? Those questions didn't have equations. They didn't have error bars. They had consequences. Because science doesn't exist in isolation. It shapes how humanity sees itself. And right now, the implications felt heavy. If this object truly behaved like a system, then someone, somewhere, had built something that crossed interstellar space. Not visited, not explored, passed through. That idea unsettled more than the thought of aliens ever had. Aliens imply presence. This implied indifference. Meetings ended with phrases like, "We need more data. We should wait. Let's be careful." No summaries, no bold statements. Just deferral. Because the data was no longer just data. It was a mirror, and people weren't sure what they saw reflected back. Some scientists worried about public reaction. Not panic, confusion, loss of trust. If the universe suddenly felt less empty, less passive, what would that do to us? Others worried about professional credibility. Careers are built on careful claims. One wrong word, one overreach, and everything collapses. But beneath those practical fears was something quieter, something human. The discomfort of standing at the edge of a truth you didn't expect to find. Trained observers are taught to push forward, to question everything, except sometimes the question pushes back. This object wasn't communicating. It wasn't explaining itself. It wasn't escalating. It was simply existing, persisting, and that made it harder to frame. How do you publish uncertainty? That feels intentional. How do you describe something that behaves too well? In one closed meeting, someone asked a simple question. What if we're not supposed to understand this yet? No one answered, because that question didn't belong in science. But it wouldn't leave. The object had not done anything dramatic. No collision. No transmission burst. Nothing that demanded urgency. And yet, it had changed the tone of the room, changed how people spoke, changed how they hesitated. Silence became the safest option, not because of fear of ridicule, but because every explanation felt incomplete. Too small, too human. Some researchers chose to step back entirely. They stopped checking updates daily, stopped running new models. They waited, not for proof, for distance. Others stayed late, staring at screens long after the buildings emptied, not searching for new anomalies, but revisiting old ones, as if hoping they'd suddenly look ordinary. They didn't. The object continued on its path, unbothered, unaware, or perhaps simply uninterested. That indifference hurt more than hostility ever could, because hostility acknowledges you, indifference ignores you. And silence is a form of indifference. In public-facing statements, language became careful. This object remains under study. Further analysis is ongoing. No conclusions can be drawn at this time. All true, all empty. Behind those words sat a growing unease, because trained observers don't choose silence lightly. They choose it when speaking feels premature, or irresponsible, or when the truth carries a weight they don't yet know how to hold. The data wasn't screaming. It wasn't demanding belief. It was waiting. And waiting is unsettling. Because waiting suggests patience, and patience suggests confidence. Whatever this object was, it didn't need us to understand it. It didn't need validation. It didn't need acknowledgement. It passed through our awareness like a thought we weren't ready to have, and that forced a difficult realization. Silence wasn't avoidance. It was respect. Respect for the limits of current understanding. Respect for the possibility that not every discovery comes with permission to explain it. As the object drifted farther away, still silent, still controlled, the scientific community remained unusually quiet. No rush to publish. No rush to name. Just observation, without interpretation. And that silence spoke louder than any headline ever could. Because when experts choose not to speak, it's not because they have nothing to say. It's because they are standing at the edge of something that may change how we see the universe, and they are deciding whether humanity is ready to hear it. So the question remains, what makes trained observers, whose lives are built on certainty, choose silence instead? And what happens when silence becomes the most honest answer science can offer? There comes a moment when looking at things separately stops making sense. Light on one screen, heat on another, motion traced across silent graphs. Individually, each anomaly could be explained away. A glitch, a rare material, an edge case of physics. But curiosity has a way of pulling threads together. And when scientists finally layered everything, the light curves, the thermal shifts, the changes in reflectivity, the timing of motion, something unexpected appeared. Not chaos, order. At first, it was just a feeling, a sense that the data was echoing itself. Light peaks lining up with temperature changes, thermal drops following reflectivity shifts, motion remaining stable when everything else adjusted. It felt coordinated, so they plotted it all together. And that's when the room went quiet. Because the pattern wasn't complicated. It wasn't noisy. It wasn't wild. It was clean. Almost too clean. The same sequence repeated. Again and again. A rise in brightness. A controlled thermal adjustment. A slight change in reflectivity. Then stillness. Like a loop. Not a perfect loop, but close enough to feel intentional. In nature, complexity is common. Efficiency is rare. Natural systems waste energy. They overshoot. They drift. This didn't. Every adjustment seemed minimal. Just enough to maintain balance. Just enough to continue forward. Nothing extra. Nothing dramatic. Someone finally said it out loud. This looks optimized. That word changed everything. Because optimization doesn't happen by accident. It happens when something is shaped by purpose, not motive. Purpose. A river finds the fastest path downhill, but it does so through chaos. This object found stability through restraint. It didn't flare when heated. It didn't spin wildly. It didn't lose mass. It adjusted, as if following a rule book we don't have. The pattern wasn't trying to communicate. It wasn't encoding information. It was simply functioning. That was the unsettling part. If this were a message, scientists could debate meaning. But this wasn't a message. It was behavior, and behavior reveals design far more honestly than words ever could. Some tried to argue randomness. If you look long enough, they said, you'll always find patterns. That's true. But randomness is messy. This wasn't. The sequence didn't drift. The timing didn't decay. The relationships between variables stayed consistent, like a machine running at low power, not doing more than it had to, not doing less, just enough. That balance felt intentional, not loud, not dramatic, quiet, efficient, the kind of efficiency you only notice when it never fails. Another unsettling detail emerged. The pattern didn't respond to us. It didn't change when observed more closely. It didn't react to increased attention. It behaved the same whether one telescope watched or 20. That indifference mattered. Because nature doesn't care if it's observed. But systems designed by intelligence also don't care, unless interaction is required. This object didn't require interaction. It wasn't curious. It wasn't probing. It was passing through, following its pattern. And that raised a question few wanted to face. What if this pattern wasn't for us? What if we were never meant to notice it at all? The thought was humbling. Because humans like to believe that discovery implies relevance, that if we see something, it must somehow involve us. But this pattern felt older, larger, unconcerned with observers, like a train schedule written for a railway no one remembers building. The simplicity of the pattern made it harder to dismiss. If it had been complex, it could be chaos. If it had been noisy, it could be error. But simple, repeated, efficient behavior. That's the signature of systems that have been refined over time, tested, improved, survived. Some researchers began to wonder how long this object had been traveling, how many stars it had passed, how many systems it had quietly threaded through without ever stopping. Because nothing about it suggested urgency, no rush, no exploration, just transit. And that idea carried a strange emotional weight, because it suggested a universe not waiting for us, not watching us, but filled with processes that move on, whether we exist or not. The pattern continued even as the object moved farther away, still stable, still consistent, as if distance didn't matter, as if location was irrelevant, only function mattered. That's when someone asked the question that changed the tone completely. If this is intentional, what does intention look like without communication? No one answered, because that question doesn't belong to astronomy. It belongs somewhere between engineering and philosophy, between science and humility. Intent doesn't always announce itself. Sometimes intent is quiet. Sometimes it's built to last, not to speak. The pattern didn't grow more complex. It didn't evolve. It didn't escalate. It simply remained. That constancy felt almost respectful, as if the object was saying nothing because it had nothing to say. It wasn't here for us. We were just in the way. As more data confirmed the same repeating sequence, resistance softened, not into belief, into acceptance of uncertainty, because denying a pattern doesn't make it disappear. It just delays understanding. And understanding may not always bring comfort. At some point, the question stopped being scientific. It became personal. At what point does a pattern stop being random and start being intentional? Is it when it repeats? When it resists explanation? When it behaves better than nature usually does? Or is it when we finally admit that intention doesn't need to look like us to exist? The object continued on its path, unchanged, uninterested, its patterns still intact, a quiet system moving through a loud universe. And maybe that's the most unsettling thought of all. That intention, when refined enough, doesn't announce itself. It simply works and keeps going. Whether we're ready to understand it or not, every object in space has a story. A birthplace, a past. Asteroids trace back to shattered planets. Comets come from distant clouds of ice. Stars are born in glowing nurseries, wrapped in dust and gas. The universe leaves fingerprints. So when scientists trace this object's path backward, they expected to find one. A cluster, a system, a familiar origin. What they found instead was nothing. No nearby star system lined up. No ancient explosion pointed the way. No gravitational breadcrumb trail led home. The trajectory didn't bend toward any known nursery. It didn't whisper a history. It stayed silent. At first, this didn't seem alarming. Interstellar objects are rare, but not impossible. Sometimes debris gets flung out, wandering between stars. But even wanderers have origins. This one didn't behave like a refugee. Its path was too clean, too deliberate, not the chaotic arc of something thrown outward by violence, but a smooth, shallow curve, like it had been placed on this route long ago and left alone to follow it. That's when probability entered the conversation, because probability is unforgiving. You can bend it, stretch it, but when it breaks, something is wrong. The odds of an object entering our system at this angle, with this speed, with this stability, were already low. Add the anomalies, the patterns, the control, and the probability collapsed, not to zero, but close enough to feel uncomfortable. Some researchers tried to salvage familiarity. Maybe it came from a dead star, they suggested. A system we can't trace anymore. Possible, but dead stars still leave echoes. Gravitational scars, motion trails, this object left none. It didn't look like it had escaped. It looked like it had arrived. That difference mattered. Escape implies accident. Arrival implies intent. Again, no one said that word. But it sat in the room, heavy, because if this object didn't form like others, then it wasn't shaped by chance. It was shaped by process, a process we don't recognize. That realization shifted the question. Not where did it come from, but what made it. Natural formation is messy. Collisions, heat, pressure, randomness sculpted over time. This object showed none of that history. No scars, no erosion, no chaos. Its structure, whatever it was, appeared preserved, maintained, as if time had been managed. That's when some scientists began to think about age. Not millions of years, not billions, but something else entirely. What if this object wasn't old in the way planets are old? What if it was timeless, not immortal, just unchanging? A tool doesn't age like a rock. It wears only when used. And this object didn't look worn. It looked intact. The idea felt unsettling. Because tools imply makers, and makers imply intention far beyond coincidence. Still, science demands restraint, so they ran simulations, millions of them. They pushed the object backward through time, testing every plausible gravitational interaction, every nearby star, every cluster. Nothing fit. The trajectory refused to intersect with known history. It didn't belong to our neighborhood. It didn't belong to any neighborhood we could map. It existed between maps. That liminal space unsettled everyone. Because humanity has always found comfort in charts, in knowing where things come from. Origin stories give meaning. This object had none. Or worse, it had one we couldn't see. Some researchers wondered if the origin question itself was flawed. What if it wasn't from anywhere? What if it was sent, not recently, not deliberately toward us, just released long ago into the galaxy, left to wander, like a message in a bottle, thrown into a cosmic ocean, not meant for a specific shore, just meant to travel. That thought felt strangely sad. Not threatening, not exciting, sad, because it suggested loneliness on a scale we rarely imagine. A civilization capable of building something that crosses stars, yet not caring where it ends up, or who finds it, or when. Some dismissed the idea immediately. This is storytelling, they said, not science. And they were right, but science begins with questions, and this object forced a new one. If it didn't form naturally, then natural explanations will always fall short. And if it didn't form naturally, then we are looking at evidence of process. Process implies knowledge. Knowledge implies intelligence. Somewhere, sometime, long ago. That doesn't mean presence now. That doesn't mean danger. It just means history is bigger than we thought. As the object moved farther away, its trajectory remained steady. No course correction, no deviation. Like a stone dropped into a river, carried by currents it didn't need to understand. That steadiness was eerie, because chaos leaves marks. This left none. The object wasn't lost. It wasn't searching. It was simply moving. Along a path chosen long before humans existed, long before Earth cooled, long before the sun was what it is now. That realization shifted perspective. We weren't observing a visitor. We were observing a survivor, something built to outlast stars. And suddenly, the universe felt older. Not in years, in intention. The question of origin lingered, unanswered, not because data was missing, but because the framework was wrong. We were asking where it came from, when maybe we should have been asking why it was made at all. That question doesn't fit neatly into astronomy. It belongs somewhere deeper, somewhere quieter, where curiosity meets humility. As the object faded into the dark, its past remained invisible. No birthplace, no history, just motion, just presence. And one final unsettling thought: if something like this can exist without an origin we recognize, then how many other processes are already unfolding in the universe? Processes we mistake for silence simply because we don't yet know how to listen. For a long time, the story belonged to scientists. Quiet rooms, dim screens, careful language. But stories don't stay contained forever. They leak. A phrase here, a headline there, an unusual object, unexplained behavior, no clear answers. And slowly, the public began to notice. At first, curiosity, then discomfort, because this wasn't framed like a discovery we've heard before. No new planet, no distant galaxy. This was closer. Not close in distance, but close in implication. People asked simple questions. What is it? Where did it come from? Why can't they explain it? And the answers felt thin, careful, guarded. That careful tone did something unexpected. It didn't reassure. It unsettled, because humans trust confidence. And here, confidence was missing. Social feeds filled with speculation. Some dismissed it as hype. Others leaned into fear. But beneath the noise, something quieter was happening. A shift. Not in belief, in perception. For generations, we've looked at the universe as a backdrop. Beautiful, vast, silent. Something we observe without being observed back. Even when we imagined life elsewhere, it was distant, hypothetical, waiting. This was different. This wasn't life waving hello. This was something behaving purposefully. Something that didn't announce itself. Something that didn't care if we noticed. And that idea changed how people felt when they looked up. The night sky didn't feel empty anymore. It felt occupied, not crowded, just not alone. Philosophers began weighing in. So did engineers, writers, artists, because the question wasn't scientific anymore. It was existential. If something artificial exists in the universe, and it's already moving through our space, then we are no longer observers at the edge of existence. We're participants, even if we didn't choose to be. That realization brought unease. Not panic, unease. The kind that lingers, the kind that follows you outside at night, when you look up at the stars a little longer than usual. Some people felt small, others felt awakened. Because discovery doesn't just reveal new facts, it reveals new limits. And this discovery hinted at a limit humanity hadn't crossed yet. We like to believe intelligence leads to communication, that if something is out there, it will speak, signal, reach. But this object did none of that. It didn't greet us. It didn't threaten us. It didn't acknowledge us at all. And that indifference was humbling, because it suggested something unsettling. That intelligence might not be rare, just uninterested. That the universe might already be full of systems, machines, processes, moving quietly, enduring, passing through, while we argue about whether they exist at all. Some felt betrayed by that idea. Others felt relieved, because a universe that doesn't care is less frightening than one that watches. But both require adjustment, a reckoning. Scientists noticed the shift too. Funding questions changed. Language changed. The way people talked about life out there changed. It wasn't about green beings or distant cities anymore. It was about presence, about artifacts, about traces, about the possibility that the universe has a memory, and we're just beginning to notice it. Observation itself felt different now, not passive, active, as if by looking closely, we were stepping into a larger story, one we didn't write, one we weren't prepared to star in. Because finding something artificial doesn't just answer questions. It creates responsibility to respond, to explain, to understand our place. And humanity isn't great at that. We struggle with perspective. We struggle with humility. We like to believe we're early, special, central. This discovery suggested otherwise. It suggested we might be late, not in technology, in awareness. Late to realize that the universe may not be waiting for intelligence to emerge, because it already has. That thought weighed on people in different ways. Some felt wonder. Others felt dread. Most felt something in between. A quiet awareness that something fundamental had shifted, even if nothing visible had changed. The object continued on its path. No messages, no returns. Just silence. And yet, the silence felt louder now, because it wasn't empty. It was full of implication. The universe hadn't changed. We had. Our questions were sharper, our confidence thinner, our sense of isolation cracked. And once that crack forms, it doesn't close. You can ignore it. You can joke about it, but you can't unsee it. Humanity has crossed many thresholds. Fire, language, flight. Each one reshaped how we saw ourselves. This felt like another threshold. Quieter, but deeper. The realization that intelligence may not announce itself, that it may exist without curiosity, without empathy, without interest in us at all. And that challenges something ancient, the belief that discovery makes us important. Sometimes discovery simply makes us aware. As the conversations grew, one question kept returning, not shouted, not argued, just whispered. Are we prepared, not for contact, but for the understanding that the universe may already be awake, and has been, long before we learned how to listen? In the end, there was no climax, no final burst of light, no last transmission, no reveal, just distance. As the object moved farther away from the sun, farther from Earth, something subtle happened. The pulses stopped, not slowly, not dramatically. They simply ended. One cycle, present. The next, gone. No farewell, no pattern change, no closing act. The monitors stayed on, the instruments kept listening, but the universe offered nothing back. At first, scientists assumed delay. Signals can lag. Data can arrive late. So they waited. Hours. Days. Nothing. The light curve remained calm. The thermal patterns flattened. Reflectivity settled into neutrality. Whatever had happened at perihelion was finished, and that finality felt strange, because humans are wired for conclusions. We expect endings to explain beginnings. We want the last page to tell us what the story meant. This story didn't, it just moved on. Some felt relief, no escalation, no threat. Others felt frustration. Years of observation, months of tension, and no answer. But beneath those reactions was something deeper, a quiet unease, because the absence felt intentional. Not broken, not failed, intentional. If this were a natural process, it might have faded unevenly. If it were damage, it would leave scars. This left nothing, like a switch turned off because it was no longer needed. That raised the question no one could avoid anymore. Was the pulse ever meant to be seen? Or were we simply in the wrong place at the right time? The idea was humbling, because humans often assume discovery implies relevance. That if we witness something, it must somehow involve us. But the universe has never promised that. Stars explode without witnesses. Galaxies collide in silence. Why should this be different? Perhaps the pulse wasn't a message. Perhaps it was a function, a response to energy input. A system checking itself, like a heartbeat rising during exertion, then settling once the strain passes. Seen from the outside, mistaken for meaning. That possibility unsettled people more than the idea of a signal ever did, because it suggested something colder, something quieter. That intelligence, if this was intelligence, might not care to communicate at all, that it might exist only to endure, to pass through, to continue without curiosity, without acknowledgement. Without us, the object continued on its trajectory. No deviation, no return. Its path led back into interstellar darkness, where it would blend into the background noise of the galaxy, untracked, unnoticed by anyone else. And suddenly a realization settled in. This might be the only moment humanity ever has with it. Not a meeting, not contact, just overlap. Two timelines briefly crossing, and that was enough to change us. Because unanswered questions linger longer than answered ones. They reshape thought. They haunt perspective. The data was archived. The debates cooled. New discoveries took the spotlight. But this one didn't disappear. It stayed quietly, in conversations, in papers, in the way scientists phrased uncertainty, in the way people looked at the night sky, with less certainty and more respect. Because silence can be an answer, not the one we want, but one we need to learn from. The universe didn't speak. It didn't explain itself. It didn't reassure us. It simply continued. And in doing so, it forced a final, uncomfortable thought. What if meaning isn't always directed? What if not every pattern exists to be understood? What if some things are not signals, but footprints, evidence of processes far older than us, moving on schedules we can barely comprehend? If that's true, then our search for truth isn't wrong, it's just incomplete. Because truth may not always arrive wrapped in clarity. Sometimes it arrives as absence, as quiet, as the realization that the universe owes us nothing, not even understanding. The object faded beyond practical observation. Its pulses never returned. No follow-up, no confirmation, just records and memory. And maybe that's the hardest part. Not that we didn't get answers, but that we glimpsed something that didn't need to answer us at all. A system, a process, a traveler passing through, indifferent, intact, leaving behind a question that refuses to settle. Was the signal ever meant for us? Or were we simply witnesses, mistaking coincidence for meaning? In a universe that continues forward, whether we understand it or not.